This final objective in this section, objective 4, is going to start preparing us for section 2.4, where we're going to be solving word problems. So we're going to be following the same steps that we followed back in section, I think it was 1.8, when we translated English into a mathematical expression, except this time we're going to be translating English into a mathematical equation, because in chapter 2 we've been dealing with equations instead of expressions. But these same steps that we followed are still going to apply. Our first step will be to read the problem, and make notes. We will still choose a variable, to represent our unknown. And since we still don't have a context, it will probably continue to be x or n. We're still going to translate the phrase, except now it's going to be translate. It'll be a complete sentence instead of just a phrase. Translate the statement. And instead of making it into a mathematical expression, we're making it into a mathematical equation. And unlike our previous section, now that we've created an equation that has an equal sign in it and a quantity on the other side of that equal sign, we'll be able to solve it. And then our final step, check with original words. Okay? And by that I mean, don't do your check by putting it back into the equation that you wrote, because if you wrote the wrong equation, you'll only be proving that you found the right answer to the wrong problem. So we need to make sure that you're checking your answer by going all the way back up to the original word statement. So let's look at a couple of examples of this. 7 more than twice a number is 19. So the 7 is still going to be a 7. More than, we learned in the previous section, means plus. Our twice is a 2. Our a number, I'll use n. And here's the word that's different. Is. Is means equals. Is 19. So writing this down, I've taken my notes. I don't have anything in here that's making me change order, although I think we did decide that 7 less than meant you had to take the 7 away. So I am going to go ahead and move that to the back, even though the commutative property tells me that 2n plus 7 and 7 plus 2n are the same thing. So I chose n to represent my unknown. I've translated it into a mathematical equation. I'm going to solve it by subtracting 7 from each side and dividing 2 on each side, leaving me with n equals 6. To check it, I'm going to read the statement again with the number 6 in here. 7 more than twice 6 is 19. So first I'd have to figure out what twice 6 is. Well, twice 6 is either 6 plus 6 or 6 times 2, which is 12, and 7 more than 12 is 19, which is exactly what it was supposed to come out. So this problem checks. In this next one, we have 3 less than My number will be n again. There's that is, which is our equal sign, 7. And as we learned in the previous section, the less than means that we're taking 3 away from this number that we know. So when we go to translate this into our mathematical statement, or our mathematical equation, the n is going to come first. Then I'll take 3 less than that n equals 7. I'll add 3 to both sides to solve it. N equals 10. And again, I check my answer with the statement. So 3 less than 10 is 7. And sure enough, if I have 10 and I take 3 less than that, I do get 7. Let's look at this next one. 7 less than 4 getting multiplied by a number. There's the magic is. The same. So is the same is another way of saying equal, or is the same as. That number is the same number they're referring to over here. So I can still use my letter n to represent it. And that n is getting increased. So it's going up by 20. Putting this into my statement, the 7 is being taken away from. It's being it's less 7 less than the 4 times a number. So I need to switch the order of those first two statements and have 4n minus 7 equaling n increased by 20. When I solve this, I get 4n, moving n to the other side, so it'll be 3n's minus 7 equals 20, or adding 7 to both sides, 3n equals 27, dividing both sides by 3, n is equal to 9. So let's see if that's true. 7 less than 4 times 9. Well, what would 7 less than 4 times 9 be? 4 times 9 is 36. 7 less than that is 27. So 7 less than 4 times a number would give me 27. And I have to make sure that that 27 I got on this side is matched on the other side. So is that the same as the number 9 increased by 20, which is 29? Okay, so somewhere I did bad math. Let me try that again. 7 less than 4 times the number. 4 times the number 9 is 36, and 7 less than 36 is 29. And that is the same as the number 9 being increased by 20. Whew. One more example of this. A number added to 5 is 4 more than 8. Find the number. So I have some number getting added to 5. So there's the number I started with, and I'm going to add that number to it, and it has to be 4 more than 8. So I start with 8 and make it go 4 more than. So my added to and my more than have both of those pieces changing places. This equation simplifies to 5 plus n equals 12. Subtracting 5 from both sides, I'll get n equals 7. To check that, 7, when you add it to 5, comes out to be 12, and 12 is also 4 more than 8, because when you take 8 and add 4 to it, you also get 12. So that one checks as well.